variable named salary. The data type of the variable will be integer, and 85,000 that you have written on the right hand side of this equal to will be stored into this variable called salary. I hope this is very clear to you. Now, moving on to this example, we have one more variable called float area. So the name of the variable will be area, and data type for this variable is float, and the value that we are trying to store into this variable called area is 64.74. This was for this line. Moving on to the next line, we are declaring a variable called volume, and this time we are using a double data type. So double volume is equals to 134.64. So as you can see, that we discussed in point number 2, the precision for double data type is very high compared to what you get in the float data type. So how can you judge about precision is by looking at the number of digits that you can use after the decimal point. This is the very basic fund of precision and accuracy that you learn in your high school mathematics. So the precision can be very clearly seen from the number of digits that you are able to use after the decimal point. So these are some examples for float, double and integers. We can also use these two data types for exponentials. I'll show you one more example how to use them for exponentials. So here, as you can see, double distance is equals to 45e12. Now let me explain this line of code. Here we are having a variable called distance. The name of the variable is distance. Now, as already discussed, the rule is before writing the name of the variable, you have to first mention the type of the variable. So the type of the variable is double. So distance is the name of the variable, and it is of the type double. And on the right hand side of the is equal to, we store the value, we write the value that we want to store into that distance variable. So 45e12 is basically 45 into 10 to the power 12. So e is used as an exponential symbol. So this basically means 45 into 10 to the power 12. So this is the mathematical meaning of the statement written over here. I hope you guys are clear with the basic theoretical concept of integers, float and doubles. So now let's move to the practical part and see some practical coding applications. Okay, so let us start with the practical discussion on our integers and float. So in the presentation, we discussed and understood some of the concepts that we require to define variables in the C++ programming language. So let me write a basic syntax, and then using the generalized statement that I'm writing in the first comment, we'll try to define some of the variables, and we'll also take some of the examples where we'll be getting user input for our integer and floating type variables. So the general syntax can be, you have your data type, and then you have a variable name, and if you are assigning the value at the time of declaring the variable, so it will turn out something like is equals to the value that you want to store. Okay, let me give some of the underscores to make it more clear. So want to store. So this will be the general syntax. Firstly, we'll write the data type of the variable that we're trying to make. Next, variable name is equals to value that you want to store. So using this generalized syntax that I've written over here, let me define 2 or 3 different variables. Before that, let me include the header files, hash include iostream, and using namespace std. This is the standard stuff that we follow in every C++ program, and here we have our main function. So let me define a variable of integer type integer where 1 is equals to 50. So let's understand the statement with the help of the generalized syntax that I have written over here in the comment. So data type is the first requirement, and here the data type is the keyword int. So what it is telling that this var1 is a variable and it is of integer type. So data type, variable name is var1 is equal to, and on the right hand side of is equal to, we'll write the value that we want to store inside this var1. So 50 will be stored into var1. If I save the program and if I try to run this, it's taking the time for compilation. Okay, we won't get any output because I'm not using any cout statement. So if I write cout and if I try to print value of var1, so I'll get 50 as the output. So as you can see on the screen, we are having 50 in the output. So this was one example for integer type variable. Let me define a floating point variable. So float var2 is equals to 75.32. So now here the syntax is exactly similar. The only things that have changed is instead of defining a variable of integer type, I am using the float keyword, which allows me to use decimal point numbers. I cannot assign decimal type numbers to the integer variables. Now if I try to print the value for var2, I'll save the code and run this one more time. So okay, what I'll do, I'll just give endl over here, so I'll get the output into two different lines. Now as you can see, for the first variable, that is var1, I'm getting 50, and for var2, that is for floating type, I'm getting a 75.32 as the output. So what else I can do is I can take user input for the variables. So what I'll do, I'll just write integer and a1. So this is just a integer type variable and I'm not assigning any value to this. And here in the next line I'll write a1 is equals to cin, and okay, not like this, I'll write cin for a1. And if I save this code and let me run it one more time, and I'm getting an option to store a value, so let's say 98. And okay, to display the value for a1, what I can do, in